Hello students, myself Shaha SR from the Chemistry Department of PC College Baramati. Today I am going to start chemical properties of alkenes. We know that alkanes are called as a paraffins, that is chemically less reactive because of nonpolar bond and inertness of sigma bond. But alkenes are more reactive than alkanes. अल्केन्सची रिॲक्टिव्हिटी ही अल्केन्सपेक्षा जास्त आहे. रिझन आहे त्याच्यासाठी ड्यू टू प्रेझन्स ऑफ पाय इलेक्ट्रॉन्स. इन अल्केन्स, two alkenes contain carbon-carbon double bond, out of which one bond is a sigma bond and one bond is pi bond, which is formed by lateral overlapping of p orbitals. This pi electron cloud is partially lies above the plane and partially lies below the plane of sigma bonded carbon atom, because of which pi bonds are weaker than sigma bond and more easily breaks. अल्किन्स मध्ये जो कार्बन कार्बन डबल बॉन्ड आहे त्यातला एक बॉन्ड सिग्मा आहे आणि एक बॉन्ड पाय बॉन्ड आहे. हा पाय बॉन्ड फॉर्म होताना लॅटरल ओव्हरलॅपिंगनी फॉर्म होतो. सो पाय इलेक्ट्रॉनचा जो क्लाउड आहे तो पार्शियली अबव द प्लेन आहे अँड पार्शियली बिलो द प्लेन आहे. बिकॉज ऑफ विच हा पाय बॉन्ड हा काय असणार आहे, वीक असणार आहे कुणापेक्षा तर सिग्मा बॉन्ड पेक्षा. सो हा पाय बॉन्ड मोर इझिली ब्रेक होतो आणि त्याच्यामुळे अल्किन्स हे जास्त रिॲक्टिव्ह आहेत अल्केन्स पेक्षा. देअरफॉर अल्किन्स आर मोर रिॲक्टिव्ह दॅन अल्केन्स. Alkenes gives following types of reaction. First one is addition reaction, second oxidation reaction, and third one is a polymerization reaction. In addition reaction, we have to study first hydrogenation, that is addition of hydrogen. Second, halogenation, that is addition of halogen. Third one is a hydrohalogenation, that is addition of hydrogen halide. And fourth one is a hydration, that is addition of water. In oxidation reaction, we have to study ozonolysis, that is addition of ozone. Second, hydroxylation, that is addition of hydroxy group, which leads to the formation of glycols. Third one is oxidation by strong oxidizing agents. So it is called as oxidative cleavage. In polymerization reaction, we have to study only linear polymerization. So by using all these reactions, alkenes form a number of organic compounds. These organic compounds are halides, 1,2-dihalides, halohydrine, alcohol, alkanes, 1,2-diols, carbonyl compounds, and cyclopropane. Then first, addition reaction. Hydrogenation, that is addition of hydrogen. Second, halogenation, that is addition of halogen. Third one is a hydrohalogenation, that is addition of hydrogen halide. And fourth one is a hydration, that is addition of water. Then first addition reaction is the hydrogenation. Then what is meant by hydrogenation? Addition of hydrogen or H2 is called as a hydrogenation. Then catalytic hydrogenation. What is meant by catalytic hydrogenation? Addition of hydrogen in presence of catalyst, then it is called as a catalytic hydrogenation. So general reaction. When H2 is added to alkene in presence of any catalyst, for example nickel, high temperature and high pressure, platinum or palladium at room temperature, then it gives alkanes, in which H2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond. So alkenes are converted into alkanes, that is unsaturated compound is converted into saturated compound. So general reaction. Here याच्यामध्ये बघा जेव्हा H2 आपण अल्किन्स मध्ये ऍड करतो इन प्रेझेन्स ऑफ कॅटलिस्ट, तेव्हा कार्बन कार्बन मधला जो पाय बॉन्ड आहे की जो वीक असणार आहे तो ब्रेक होतो आणि तिथं न्यू सिग्मा बॉन्ड फॉर्म होता बिटवीन कार्बन अँड हायड्रोजन. इट मीन्स double bond is converted into single bond, that is alkenes are converted into alkanes. alkenes. These are the examples of hydrogenation. When H2 is added to ethene in presence of catalyst, then H2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond, that is ethene is converted into ethane, that is unsaturated compound is converted into saturated compound. Second, when H2 is added to propene in presence of catalyst, then H2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond, that is propene is converted into propane, that is unsaturated compound is converted into saturated compound. Then addition reactions. Alkene shows two types of addition reaction. First one is the electrophilic addition reaction and second one is the free radical addition reaction. Then next point is the electrophilic addition reaction. Can you tell why alkenes undergoes electrophilic addition reaction? Alkenes electrophilic addition reaction का दाखवतात? त्याच्यासाठी reason आहे बघा. We know that alkenes contain carbon-carbon double bond, out of which one bond is sigma bond and one bond is pi bond. This pi bond is formed by lateral overlapping of p orbital. So this pi electron cloud partially lies above the plane and partially lies below the plane. So this pi bond is weak bond than sigma bond and breaks easily. So alkenes are rich source of weakly or loosely held pi electrons. Alkene हा rich source आहे weakly किंवा loosely held pi electrons चा. These loosely held pi electrons are easily available to any reagent that is in need of electrons, that is electron deficient reagent called as electrophile or electron loving. हे जे लूजली हेल्ड पाय इलेक्ट्रॉन्स आहेत ते अशा कोणत्याही रिएजंट साठी इझिली अवेलेबल होतात की जे इलेक्ट्रॉन डिफिशियंट असतात त्यांनाच आपण इलेक्ट्रोफाइल्स म्हणतो, म्हणूनच ते इलेक्ट्रॉन लविंग असतात. सो अल्किन्स ऍक्ट्स ऍज अ सोर्स फॉर इलेक्ट्रोफिलिक अटॅक. याच्यामध्ये बघा कार्बन कार्बन डबल बॉन्ड आहे, त्यातला एक बॉन्ड सिग्मा आहे आणि एक बॉन्ड पाय बॉन्ड आहे. This pi bond are rich source of loosely held pi electrons. So electrophile, which is electron deficient or electron loving, is attached to this carbon and it forms carbocation in first step. In second step, nucleophile is attacked on this carbocation and it forms a addition product. So alkenes attacked by electrophilic reagent, so they show electrophilic addition reaction in which electrophiles, here this is the electrophiles, add on carbon-carbon double bond to form a addition product. Same as to electrophilic addition reaction, alkenes also undergoes free radical addition reaction where attacking reagent called free radical just need an electron. Then halogenation. Halogenation means addition of halogen when X2 is equal to Cl2 or Br2. F2 is too reactive, so that type of reactions are explosive. I2 does not add or fails to react because of their larger atomic size. Halogenation of alkenes is also electrophilic addition reaction. Then next point, halogenation of alkenes in presence of nonpolar solvent. When alkene is treated with bromine or chlorine in CCl4, that is carbon tetrachloride, or some other inert solvent at room temperature, the halogen adds rapidly to double bond of alkene to give the corresponding vicinal dihalide or dihaloalkane. It means जेव्हा अल्किन रिॲक्ट करतो ब्रोमीन आणि क्लोरीन बरोबर in presence of CCl4 at room temperature, then it gives a vicinal dihalide or dihaloalkane. Then general reaction. When X2, that is halogens, which is Br2 or Cl2, is added to alkene in presence of CCl4 at room temperature, then it gives a vicinal dihalide or dihaloalkane. That is, when X2 is added to alkene, then it's added across the carbon-carbon double bond, because of which this double bond is converted into single bond and it gives a vicinal dihalide or dihaloalkane. X2 ची ऍडिशन केल्यानंतर कार्बन कार्बन मधील पाय बॉन्ड ब्रेक होतो आणि टू न्यू सिग्मा बॉन्ड बिटवीन कार्बन अँड हॅलोजन फॉर्म होतात, म्हणजेच आपल्याला विसिनल डायहॅलाइड मिळतो. देन व्हॉट इज मीन बाय विसिनल डायहॅलाइड? Two halogen atoms attached to the adjacent carbon, then it is called as a vicinal dihalide. Here two halogen atoms attached to the adjacent carbon, म्हणजे शेजारी असणाऱ्या कार्बनला हे दोन halogen atom attached आहेत, so it is called as a vicinal dihalide. Then first reaction is chlorination of alkenes, means addition of chlorine across the carbon-carbon double bond in alkene. Then example, ethene on chlorination in presence of CCl4 at room temperature, it gives ethylene dichloride or 1,2-dichloroethane. Here, when Cl2 is added to ethene or ethylene in presence of CCl4 at room temperature, then it gives a 1,2-dichloroethane or ethylene dichloride, in which Cl2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond to give 1,2-dichloroethane or ethylene dichloride. जेव्हा आपण Cl2 चे ऍडिशन करतो इथिन मध्ये in presence of CCl4 at room temperature, then Cl2 ऍड होतो कार्बन कार्बन डबल बॉन्डला, त्याच्यामुळे ह्या डबल बॉन्डचं कन्वर्जन सिंगल बॉन्ड मध्ये होतं आणि आपल्याला 1,2-डायक्लोरोइथेन किंवा इथिलीन डायक्लोराइड हा प्रोडक्ट मिळत असतो. Then questions. What is the action of Cl2 in presence of CCl4 on following alkenes? Propene, but1-ene and pent1-ene. When propene reacts with Cl2 in presence of CCl4 at room temperature, it gives a 1,2-dichloropropane, in which Cl2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond. Then second example, when butene reacts with Cl2 in presence of CCl4 at room temperature, then it gives a 1,2-dichlorobutane, in which Cl2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond. Then when pentene, pent1-ene म्हटलेलं आहे, here position of its double bond in between carbon atom 1 and 2, so it is a pent1-ene, react with Cl2 in presence of CCl4 at room temperature, then it gives a 1,2-dichloropentane, in which Cl2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond. Then next, bromination of alkenes, means addition of Br2 across the carbon-carbon double bond in alkene. Color of bromine is brown-red. Then examples. When ethene reacts with Br2 in presence of CCl4 at room temperature, then it gives a 1,2-dibromoethane, in which Br2 is added across the carbon-carbon double bond in alkene. So, double bond in alkene is converted into single bond to give the 1,2-dibromoethane or ethylene dibromide. Then second example, when propene react with Br2 in presence of CCl4 at room temperature, then it gives a 1,2-dibromopropane, in which Br2 is added across the carbon-carbon double bond, because of which double bond is converted into single bond to give a 1,2-dibromopropane or propylene dibromide. Then questions. What happens when following alkenes react with Br2 in presence of CCl4, but1-ene and paint1-E? Here, but1-ene, position of double bond is in between carbon atom 1 and 2, so it is a but1-ene react with Br2 in presence of CCl4 at room temperature. Then it gives a 1,2-dibromobutane in which Br2 is added across the carbon-carbon double bond of butene. So it forms a 1,2-dibromobutane or butadiene dibromide. Then same, pentene react with Br2 in presence of CCl4 at room temperature. Then it gives a 1,2-dibromopentane in which Br2 is added across the carbon-carbon double bond in alkene, because of which double bond is converted into single bond to form a 1,2-dibromopentane. Then next point is test for unsaturation. Give a chemical test to distinguish between alkanes and alkenes. And second question, how will you distinguish between propane and propene? So answer of this question, the addition of bromine dissolve in CCl4 or water known as bromine water used as a test for unsaturation. So addition of bromine in CCl4 or addition of bromine in water used as a test for unsaturation. Then test for alkenes. Step first, test tube containing bromine water or Br2 in CCl4. या टेस्ट ट्यूब मध्ये ब्रोमीन वॉटर किंवा Br2 in CCl4 आहे. स्टेप सेकंड, ऍड अल्केन टू द ब्रोमीन वॉटर और Br2 in CCl4. टेस्ट ट्यूब मध्ये आता आपण अल्कीन ऍड करतोय. देन स्टेप थर्ड, ती टेस्ट ट्यूब आपण शेक करणार आहोत. देन स्टेप 4 आपल्याला ऑब्झर्वेशन मिळते, द ब्रोमीन वॉटर turns colorless, confirming the presence of alkenes. ब्रोमीन वॉटरचा कलर हा ब्राउन आहे आणि आफ्टर शेकिंग आपल्याला ऑब्झर्वेशन मिळते की कलरलेस सोल्युशन मिळालं आपल्याला तिथं. त्याच्यावरून हे कन्फर्म होतं की त्याच्यामध्ये जो आपण ऍड केला सबस्टन्स तो काय असणार आहे, अल्कीन असणार. If bromine is added to alkene or alkyne, the brownish color of bromine is disappear because bromine is used up in addition reaction. That is, bromine is adds across the carbon-carbon double bond in alkene or carbon-carbon triple bond in alkynes. Then example, when Br2 is added to ethene, then it gives a 1,2-dibromoethane in which Br2 is added across the carbon-carbon double bond in ethene, because of which double bond is converted into single bond. That is, bromine is used up in addition reaction. That is, bromine adds across the carbon-carbon double bond in alkene, because of which brownish red color of bromine is disappear. It confirms that compound is unsaturated compound. So test Br2 in CCl4 test or bromine water test. Organic compound plus Br2 in CCl4 or Br2 water. Brown color of bromine is disappear or decolorize. It means unsaturation is present. Then test for alkanes. Step first, टेस्ट ट्यूब कंटेनिंग ब्रोमीन वॉटर और Br2 in CCl4. या टेस्ट ट्यूब मध्ये ब्रोमीन वॉटर किंवा Br2 in CCl4 घेतलेला आहे. स्टेप सेकंड, ऍड अल्केन टू द ब्रोमीन वॉटर और Br2 in CCl4. या टेस्ट ट्यूब मध्ये आता आपण अल्केन ऍड करतोय. स्टेप थर्ड, ही टेस्ट ट्यूब आपण शेक करत आहोत. स्टेप 4, आफ्टर शेकिंग there is a no change in color to bromine water is observed. So, confirming the presence of an alkane. ब्रोमीन वॉटरचा कलर हा ब्राउन आहे आणि आफ्टर शेकिंग सुद्धा आपल्याला ब्राउन कलरच मिळतो. इट मीन्स त्या ब्रोमीन वॉटरच्या कलर मध्ये काहीच चेंज होत नाही. याच्यावरून हे कन्फर्म होतं की आपण ऍड केलेला कंपाऊंड हा अल्केन होता. So, if bromine is added to alkane, the brownish color remains or does not disappear. Alkanes are saturated or contain single bond. They do not undergo any reaction with bromine. Alkanes हे सॅच्युरेटेड कंपाऊंड आहेत, त्याच्यामध्ये सिंगल बॉन्ड आहेत, त्यामुळे ते कोणत्याही टाइपची ऍडिशन रिॲक्शन ब्रोमीन बरोबर दाखवत नाहीत. इट मीन्स ब्रोमीन डज नॉट यूज or does not add to carbon-carbon bond. So brown color of bromine remains or does not disappear. So test Br2 in CCl4 or Br2 water test, organic compound plus Br2 in CCl4 or Br2 water. Brown color of bromine does not disappear or decolorize. It means unsaturation is absent, that is compound is alkane. बघा आपण एक टेस्ट ट्यूब घेतलेली आहे आणि त्या टेस्ट ट्यूब मध्ये एक ऑर्गॅनिक कंपाऊंड घेतलेला आहे. हा कंपाऊंड सॅच्युरेटेड आहे की अनसॅच्युरेटेड आहे हे आपल्याला डिटेक्ट करायचंय आणि ते डिटेक्ट करण्यासाठी आपण त्याच्यामध्ये Br2 in CCl4 ऍड करतोय. आफ्टर ऍडिशन आपल्याला दोन पॉसिबल ऑब्झर्वेशन्स मिळू शकतात. फर्स्ट ऑब्झर्वेशन आपल्याला कलरलेस सोल्युशन मिळू शकतं. जर आपल्याला कलरलेस सोल्युशन मिळालं तर त्याचं मीनिंग असं आहे की टेस्ट पॉझिटिव्ह आहे. इट मीन्स Br2 reacts implies the presence of double bond. मीन्स Br2 जेव्हा आपण त्या टेस्ट ट्यूब मध्ये ऍड करतो आणि टेस्ट ट्यूब मध्ये प्रेझेंट असलेला कंपाऊंड जर अनसॅच्युरेटेड असेल तर Br2 त्या अनसॅच्युरेटेड कंपाऊंड बरोबर रिॲक्ट होतो. म्हणजेच Br2 त्या कार्बन कार्बन डबल बॉन्डला ऍड होतो आणि त्याच्यामुळे त्या डबल बॉन्डचं कन्वर्जन हे सिंगल बॉन्ड मध्ये होतं. या सगळ्या प्रोसेस मध्ये Br2 हा यूज केला जातो. मग त्याच्यामुळे Br2 चा ब्राऊन रेड कलर हा डिसअपियर होतो आणि आपल्याला तिथं कलरलेस सोल्युशन मिळतं. बट जर आपल्याला सेकंड ऑब्झर्वेशन असं पण मिळू शकतं की तो ब्राऊन रेड कलर ऍज इट इज तसाच राहतो. त्याचं मीनिंग असं असणार आहे की ती टेस्ट निगेटिव्ह आहे. इट मीन्स Br2 इज नॉट डिकलराइज और डज नॉट रिॲक्ट. म्हणजे Br2 हा डिकलराइज होत नाहीये किंवा तो रिॲक्ट होत नाही. इम्प्लाइज दॅट द डबल बॉन्ड इज नॉट प्रेझेंट. Br2 कधी रिॲक्ट नाही होणार जर दिलेल्या कंपाऊंड मध्ये डबल बॉन्ड प्रेझेंट नसेल तर तो रिॲक्ट होणार नाही. म्हणजे Br2 ऍड होऊ शकत नाही. Br2 ऍड होत नाही म्हणजे Br2 यूज केला जात नाही. म्हणून त्याचा ब्राऊन रेड कलर ऍज इट इज तसाच राहतो की जे हे कन्फर्म करतो की दिलेला कंपाऊंड हा सॅच्युरेटेड आहे आणि त्याच्यामुळं तिथं Br2 हा यूज केला जात नाही किंवा Br2 हा ऍड होत नाही. This test is used to distinguish between alkanes and alkenes or cycloalkanes and alkenes. Because alkanes and cycloalkanes are saturated compounds, so brown color of bromine does not disappear because bromine does not used up in reaction. Alkenes are unsaturated compounds, so brown color of bromine is disappear, that is bromine is used up in reaction. Then this is your homework. Thank you so